Hello friends, welcome to Science Blue. Today we are going to discussing about the topic null points. This is a topic in the chapter electrostatics, and our topic is null points between the charges. First of all, let's check what do you mean by null point. Okay, so whenever you see null point, it means net force acting at that point is zero. Null point means the net force acting at that point is zero. So let us check how to find out the null point between two charges. Okay. So consider there are two charges. One is plus q1 and other one is plus q2. And here the distance between these two charges is small r. And there is one more thing you have to consider, that is the magnitude of q1 is less than the magnitude of q2. You have to keep in remember that magnitude of q1 is less than magnitude of q2. Okay, now we want to find out in between these two charges where will be the null point will be formed. Okay, for that you do one thing, just place a charge plus capital Q in between these two charges. Okay, so let the distance from plus q1 to plus capital Q is x, and from plus capital Q2 plus q2 it is r minus x. Okay. Now this charge q1 will exert a force on plus q, and that is F1. F1 is a force on plus capital Q by q1. Similarly, the charge plus q2, it exerts a force on plus q1, and that is F2. And please note that this is plus q1 and this is plus q. So two like charges. So we know that the force between two like charges is repulsive in nature. So F1 will act in this direction. Similarly, F2 will act in this direction. Okay. Now let us check where will be the null point will be formed. Okay. For the formation of null point, this is F1 plus F2. It must be 0, or it can be cancelled each other. For the cancellation of F1 and F2, the magnitude of F1 must be equal to magnitude of F2, and they must act in opposite direction. They must act in the opposite direction. So in order to find out the null point, the position of null point, just equate magnitude of F1 with magnitude of F2. And I already told you that magnitude of Q1 is less than magnitude of Q2. Now you have to remember one thing, null point will be formed near to the charge having lesser magnitude. I repeat once more, null point will be formed near to the charge having lesser magnitude. So it will form near Q1, that is at x. The null point will be formed at x from the charge plus Q1. Okay, now equating magnitude of F1 and F2. The magnitude of F1 can be written as F1 equals K Q1 capital Q by x square, while that of F2 is given as K Q2 into capital Q by r minus x the whole square. So this capital Q and K, that is cancel off. So Q1 by Q2 equals x square by r minus x the whole square. Taking square root on both sides, root of q1 by q2 equals x by r minus x. So on cross multiplication, r into root q1 minus x into root q1 equals x root q2. From this, r into root q1 equals root q1 plus root q2 into x. And from this, the value of x equals r into root q1 by root q1 plus root q2. So here the null point will be formed at a distance x from the charge having lesser magnitude. This is the case of same charges. Now consider the case of unlike charges. Okay, take the case of unlike charges. So let's see where will the null point will be formed. So consider two charges. This is plus q1 and this one is minus q2. So these are the two unlike charges, right? And here the distance between these two charges is taken as small r. Now we need to find out where will be the null point will be formed. For that, we just place a charge q here plus q here. Now the force between plus q1 and q2, I'm sorry, this is q1. The force between plus q1 and plus capital Q, it is repulsive in nature because of the unlike charges, proper properties of electric charges. So let that force be F1. It is acting along this direction. Now the force between, or the force exerted by minus q2 on plus q, it is attractive in nature and it will act on along this direction, that is force B F2. So here two forces are in the same direction, so they will not get cancelled, they will add it up. So in this situation, the null point will be formed out of the system. When in the case of like charges, it will be formed inside the system or inside between q1 and q2. But in the case of unlike charges, it will be formed outside the system. Okay, so let's check. So this is plus q1 and this is minus q2, and the distance of separation between them is r. Now I am placing a charge plus q here. It is outside system, and I already told you that the magnitude of q1 is less than magnitude of q2. So the null point will be formed near plus q1. So let the null point will be formed at a distance x from q1. Now this q1 exert a force on plus q. It is repulsive, so it will act in this direction. Similarly, minus q2 will exert a force on plus q. It is attractive, so it will be acting along this direction. So at this point, this F1 and F2 gets cancelled, so the net force is 0. So we need to find out the value of x. Just equate the magnitude of F1 with magnitude of F2. So that the magnitude of F1 is given as k q1 q by x square equals magnitude of F2 equals k q2 q by r plus x the whole square. So that is q1 by x square equals q2 by r plus x the whole square. So on rearranging, q1 by q2 equals x square by r plus x the whole square. So taking square root on both sides, root of q1 by q2 equals x by r plus x. So it's root q1 into r plus root q1 into x equals root q2 into x. So root q1 into r equals root q2 minus root q1 into x. Therefore x equals root q1 into r by root q2 minus root q1. So in the case of unlike charges, the position of null point is given as x and is given by the corresponding equation. Okay, thank you.